Happy day students, welcome to class 10 physics, chapter 13 magnetic effects of electric current, part 1. In the previous chapter on electricity, we learnt about the heating effect of electric current. What could be the other effects of electric current? We know that an electric current carrying wire behaves like a magnet. So magnet, a substance which attracts small pieces of iron and points in north to south direction when suspended freely in known as magnet. A naturally occurring iron ore, which is called as lodestone or magnetite, also behaves as a magnet, but it is very weak magnet. The ones we are made from them in artificial way and permanent and strong. So magnet have properties. It has two poles, north and south pole. Like poles repel each other and unlike poles attract each other. They always exist in pairs of poles. The repulsion is the only sure test for a magnet. Now activity 13.1. Take a straight thick copper wire and place it between the points X and Y in an electric circuit as shown in figure. You can see the circuit diagram, which is we are connecting the series devices, that is series connection, ammeter, variable resistance and long straight conductor, and we have across the plain paper, and we are kept the compass needle near to the copper conductor, and we have a key and again the variable resistor and battery. Horizontally place a small compass near to this copper wire. See the position of its needle. Pass the current through the circuit by inserting the key into the plug. Observe the change in the position of the compass needle. We see that the needle is deflected. What does it mean? It means the electric current through the copper wire has produced a magnetic effect. Thus we can say that electricity and magnetism are linked to each other. Then what about the reverse possibility of an electric effect of moving magnets? So in this chapter we will study magnetic fields and such electromagnetic effects. We shall also study about electromagnets and electric motors which involve the magnetic effect of electric current, and electric generators which involve the electric effect of moving magnets. Magnetic field and field lines. Magnetic field, the region around a magnet where the force of attraction or repulsion can be detected, is called magnetic field. Magnetic field around a magnet can be detected by using a magnetic compass. You can see the bar magnet. We have a north and south direction. We are kept the compass needle, which the direction of the needle in south side, it is towards the north, and when you are keeping the compass needle near the point of north pole, it deflects towards the south direction. Magnetic field lines. Magnetic field lines are the paths around a magnet along which the north pole of a magnetic compass needle tends to move. The magnetic field lines around a magnet can be observed by sprinkling iron fillings around a magnet. It can also be observed by moving a magnetic compass around a magnet. The magnetic field lines emerge at the north pole and merge at the south pole. The magnetic field lines are closer at the poles. The magnetic field lines do not intersect each other. Why does a compass needle get deflected when brought near a Bohr magnet? The needle of a compass is a small magnet. That's why when a compass needle is brought near a Bohr magnet, its magnetic field lines interact with that of Bohr magnet, hence a compass needle gets deflected. We have magnetic field due to a current carrying conductor. If a magnetic compass is placed near a conductor carrying current, the needle is deflected. This shows the conductor carrying current has a magnetic field around it. If the direction of the current is from north to south, the deflection of magnetic needle is towards the east. If the direction of the current is from south to north, the deflection of the needle is towards the west. The magnetic field around a current carrying straight conductor is in concentric circles. You can see this diagram when you are having a cardboard which is connected with the straight conductor. When you are connecting with north to south direction, the direction of the needle which is deflects it a west direction, and if you are turning the conductor which you are creating the current which is opposite to the direction of north to south, you will get the deflection from east. Okay, so here the magnetic field around a current carrying conductor is in concentric circles. It can be observed by passing a current carrying straight conductor through a cardboard and sprinkling iron fillings on it. Right hand thumb rule. The direction of magnetic field around a conductor is given by right hand thumb rule. It states that if a current carrying conductor is held in the right hand such that the thumb points in the direction of current, then the fingers wrapped around the conductors shows the direction of the magnetic field. A current through a horizontal power line flows in east to west direction. What is the direction of the magnetic field at a point directly below it and at a point directly above it? Answer is the current is in the east-west direction. Applying the right hand thumb rule, we get the magnetic field at any point below or above the wire turns clockwise in a plane perpendicular to the wire when viewed from the east end and anti-clockwise when viewed from the west end.